Hello, scholars, and welcome to Lesson 8, Session 2. This is basically our objective today. Our objective is to do this. It is to show that slope is a line, show that the slope of a line is constant. We are going to show that the slope of a line is constant. Last lesson, we started to talk about this idea of slope. We played with this idea a little bit. We talked about it being a rate, kind of harked back to sixth grade math a little bit, when we talked a lot about rates and unit rates and things like that. Today, we are going to talk a little bit more of that, a bit more about that actually. So let's look at this problem. It says a delivery company uses robot dogs to deliver packages in an office building. The graph shows how long a robot dog can operate for each hour its battery is charged. Pick any 2 points on the line and find the slope of the line between these 2 points. Can you find another pair of points on the line that give you a different slope? Okay, so what do we know about slope? We started to talk about it's like this change in the vertical divided by a change in the horizontal of your graph. I want to kind of formalize that a little bit for us. I'm sorry that this is so dark on my page, but it should be a lot lighter on yours. I'm going to pick a couple points here. Kind of like this one and this one. I see a point here. I see a point here. Let's make some dots there, okay? Hopefully your dots show up better than mine, right? Okay, and now before we finish kind of calculating these, I want to talk down here a little bit about slope. And these are going to be really important notes to get down, okay? I want to talk about slope. We already started to talk about this idea that slope is a change in my vertical divided by a change in my horizontal. Now, maybe we can say that a little differently, actually. We could say that this is a change in my y values divided by a change in my x values. And I'm going to say that even a little bit more fancy. I'm going to say that this is delta y divided by delta x. Where does this idea of delta come from? Well, delta is a Greek letter. Looks like a triangle. Delta means change in, okay? So I always like to give you some symbols to represent things that we use a lot in math, and this is one of them. A change in my y, delta y, divided by a change in my x, delta x. Okay, so we've got these ideas written down, and there's a couple different other ways that we're going to represent this, okay? And I'm going to give them to you now, and we will use them, some of them today, and one we're going to use tomorrow. We're going to say that we could also call slope rise over run. And I don't think we necessarily need this one, but a lot of people like to use it when teaching how to find slope given a graph. So if this is helpful for you, think about how much do I rise divided by how much do I run, okay? Also, we can think about, and here's the last one I'm going to give you, y2 minus y, oops, that's supposed to be a y, minus y1 divided by x2 minus x1. Now I'm going to save explaining this for next lesson, okay? But I wanted you to have this so that we can have all the ways we're going to represent slope this year. Okay, now these first ideas, delta y divided by delta x, I think this is really good to think about if I have a table. Okay, I think that's really a good way to think about a table. How is my y changing, and divide it by how my x is changing. I think rise over run, the only time we want to use that is if we have a graph. And then we can use this. This is actually called the slope formula, y2 minus y1 divided by x2 minus x1. We can use that when we have 2 points. We could also say that we could use this any time. Oops. Make a G there. Anytime. Anytime I want to, I can really use that, okay? I mean, it's a little bit more math, which is why we like to use rise over run or things, but especially when we have 2 points, we're going to use this idea, but anytime I can use this as well to get my slope. So that was a lot. Back to my problem now. It wants us to find the slope, a slope between these 2 points. So I can think any of these ideas. I'm thinking, how is my y changing divided by how is my x changing? So I'm going to think about how is my y changing. Well, it looks like it is going up 10, 20, 30. It's going up 30. So my slope here, my slope. I'm thinking again, rise divided by run, or a change in my y divided by a change in my x. Anyway, I think about it here, it looks like we're rising. It looks like my y is changing by 10, 20, 30. Divided by how is my x changing? Well, it looks like it is going over, this is a 1. It looks like it is going over 1. So it's going up 30 and over 1. Well, 30 divided by 1 is 30. And we're going to say 30 what? 30, it's going up what? Operating time. 30, we get 30 minutes of operating time per hour. We get 30 minutes of operating time per hour. Okay. And I wonder if that stays the same if we pick any other 2 points. And that is what's on this next page, okay? Showing us these different representations. So that what did we do? We said, well, I'm going to pick this point and this point. Notice that these points that I picked perfectly hit the grid lines. Both the y and the x, they perfectly hit. Those are the kind of points we want to pick because we know exactly what their value is. And we said that this went up 30 and it went over 1. 30 divided by 1. And so the other question was, does it matter which 2 points I pick? Well, it doesn't look like I do. 30 over 1. 30 over 1. They made our triangles on the bottom. I hate when books do that because we measure this first, the vertical change first, and then measure the horizontal change over. But it didn't really seem to matter what 2 points I picked. It doesn't even matter if I pick 2 points that are really far away. Either way, look at this. I'm going up 60 and over 2. Well, what is 60 over 2? Well, that equals 30, right? 60 divided by 2 is 30. It doesn't matter if I go up 90 and over 3. 90 over 3, well, 90 divided by 3 is 30. I still get the same number no matter what I do. I keep getting this 30. No matter what points I pick, I get 30. So let's kind of sum that thought up a little bit here. Are these triangles congruent? Are these triangles that we made here, are they congruent? Congruent means the same measurement. We're going to say yes. Their side lengths are the same. Their side lengths are the same. Of course they're congruent. Of course they're the same shape. How can we use ABE to determine the slope of the lines between point A and B? What is the slope? Well, we are going to say how much does it go up and how much does it go over. We are going to take the change in our vertical divided by our change in the horizontal. And we found out that was 30 divided by 1, which gave us 30, our slope. So we think about how is this changing vertically and how is it changing horizontally, and we get our slope. Is the slope between points A and B the same as the slope between B and C and C and D? Well, we did that, right? 30 over 1. We're going to say yes. Oops, I'm right here. Yes. Explain. Same change, both vertically and horizontally. I get the same change. Okay, number 2, look at the model it. What is the slope of the line between A and B? What is the slope of the line between A and D? Well, we said not yes, but 30. It's 30. We looked. Okay, both models started by choosing point A, B. How do you know the slope of the line is the same between any 2 points? Let's just say this. Because the quotient, ooh, that means division. Ooh, I definitely spelled that wrong. I think that's better. Quotient of the change in my y divided by the change in my x always, that should be 1L, always reduced to the same number. No matter what 2 points we picked on that line, right? We got the same number. We picked A and D. We went up 60 over 2. We still got 30. We went up 90 over 3. We still got 30. We got 30 no matter what 2 points we picked on this line. We got 30. Okay, let's try a few more problems before we have to go. I know this video is getting a little long, but this is a really important lesson. So our friend here sells honey. She posts this sign for our customers. Then she makes the graph that shows the price of each size of jar. Is her price the same per ounce for any size jar? Well, let's check. I go up and over, up and over. So let's think. What is that? That's a change from 0 to, it says the price is 5 here. So my delta y divided by delta x. My rise overrun. What is that? Well, how much do I go up? It looks like I go up 5, right? Looks like I'm going up 5, and I'm going over 4. Let's try this. It looks like I'm going up, what is this going to be? 12.5? And I'm going over 10, right? I wonder if those are the same numbers. Let me grab my calculator and we can check that out together. I don't know, somebody took my calculator off my desk. Don't worry, I will grab one real quick out of my backpack. Okay. Let's try this first. I'm going to just simplify this. I usually want you to leave it in a fraction. Usually want you to leave it in a fraction like this. That is almost always much better. But since we're talking about money, it's okay to write it as a decimal. Okay? Ooh, 5 divided by 4, that's 1.25. Ooh, I think we just got a unit rate. A unit rate. We might talk about that idea a little bit. 12.5 divided by 10. Oh, that's 5/4. Oh, that's 1.25. Oh my gosh. What if we go up? What if we go up? Ooh, this is going to be 18.75. What if we go up 18.75 and we go over, what is this, 15? I wonder. 18.75 divided by 15. Oh my gosh. Oh my goodness. It doesn't matter. It doesn't matter what point I pick. It's always going to cost, it costs $1.25 per ounce. Per ounce we buy of this honey. It's always going to cost us $1.25 per ounce. Okay. Our friend here draws a graph to record the distance he rides on a long bike ride. What is the slope of the line for the first 2 hours? What is the slope of the line for all 5 hours? What does it mean in this situation? Okay, for this first 2 hours, well, it looks like it's going up 20 and over 2, doesn't it? 20 over 2. Rise over run. 20 over 2. 20 divided by 2 is 10, isn't it? 10. What about if I do the first 5 hours here? We're going up 50 over 5. 50 over 5. Oh, I think that 50 divided by 5, that's 10, isn't it? That's 10. What does it's always going to be 10, isn't it? What does the slope of the line mean in context of this situation? This means that that he is riding his bike.
If there are any students still in the school, both buses are here.
He's riding his bike 10 miles per what? 10 miles, my change in my y, what does my y represent? It represents miles, right? 10 miles, what does my x represent? Because that's what we're comparing here, per hour. He is riding his bike 10 miles per hour constantly. He's never going to stop riding 10 miles per hour. He's not slowing down. He's not speeding up. He is just continuing to ride. Okay. This person drew a graph. Man, they're giving me hard names. To describe her airplane trip. Is the slope constant for the entire trip? Well, it sure doesn't look like it, does it? Because it looks like it's changing right there. I go up 300 over 2, which equals 150. Compared to, if I do this to this point, it looks like we go up another 300 compared to 300 compared to, what is this, 3. So that's 1, 2.5, 2.5. Well, 300 divided by 2.5 equals 120 miles per hour compared to 125 miles per hour, or 150 miles per hour. So it looks like her slope is not constant. Well, but we said it was always going to be constant because she did not make a straight line. Okay, I'm sorry that video was on the long side, but it was so important that we got through that. I hope that was helpful, and you should know what to work on next. Thank you.